Hello, calculus fans. Let's evaluate these limits. So it's a limit as x approaches negative infinity. One of them is e to the x squared. The other is e to the minus x squared. Now in both cases, we're able to pass the limit through the exponential, and that's because of the continuity of the exponential function. For example, if we want to take the limit as x approaches negative infinity of e to the x squared, that turns into e raised to the limit as x goes to minus infinity of x squared. Now, it's a little unwieldy to have exponential functions where the exponent is itself complicated. So I'm going to introduce a new method of writing these things, and this is a standard notation. Instead of e to the w, we'll write exp of w. So if w is a complicated expression, you don't have to stick it in an exponent. All right, so with that in mind, we'll write the limit as x approaches minus infinity of e to the x squared is equal to exp of the limit as x approaches minus infinity of x squared. Now we know that t, if we call t this limit, that thing is going off to infinity, and so that means the limit as x approaches minus infinity of e to the x squared, which is equal to the limit as t goes to infinity of e to the t, that's infinity. Now in our second limit, we're going to again pass the limit through the exponential. So the limit as x approaches minus infinity of e to the minus x squared, we're going to do the same kind of thing, but this time it's different. This time, this s on the inside, this limit here, it's going off to minus infinity. And so now, when we rewrite the limit and cast it in terms of an s, now s is going off to minus infinity. See, now if you have e to the s, now before, e to the s went off to infinity because the s was going to infinity. Remember that the graph of the exponential function goes off to infinity when the independent variable gets very large. But if the independent variable is getting very large on the negative side, you're going to go off to 0. So it's a little different. Okay, that's all for now.